basically, yeah. I mean, should we just get into it?
Let's
Should we
just do it,
start it
dude.
up?
Yeah.
Yeah.
First off,
You want me to record as well, or
I
we all
think
record?
Yeah, I'm doing it just in case, but yeah.
Okay. All right. Cool.
I think
All right.
yeah.
I don't
if
have
we-
permission, anyways.
Exactly. That means that's where we're at right now. You don't get any permissions for that. So, all right, dude. Well, after a bumpy start, looks like we can finally get into it.
Yeah.
The last time that we met, David and I talked about serving models through what was it? KF serving. Yeah, Kubeflow. And we learned that you gotta serve it up hot, always serve it fresh. no kinds of no stems, no seeds, just serve it
That's
right. And so now this time we're just going to talk about serving in general, and we're going to be looking at this blog post that David found. And so let's just get into it, man. Like,
you want me to introduce the author and kind of how, because we haven't mentioned him last time, but his name is Bugra and forgive me for butchering your name, Akyildiz. He's a senior engineering manager at Jet, where he leads a large search engineering team. And he has a lot of other good blogs that I've been checking out. I like the way he writes. Very clear.
Cool. So
Bugra.
What's it about, man? I understand serving, but there's he breaks it down in a really easy to follow way.
Yeah. So I guess the gist of the article is he articulates 3 common patterns or paradigms for deploying a model into production or serving a model. And he really talks about the pros and cons and does it in like a very simple and succinct way. And a lot of people that have read this found it very helpful just because of how simple it is, which is something that's always good.
All right, nice. Now, Byron, when you were reading through this, did you notice anything that like caught your attention right away?
Yeah, I mean, he basically looked at it from 3 patterns, right? So there's 3 patterns that he identified that he saw as like really prevalent. And I would say that I've seen those 2, although one of them I haven't really thought that much about. I've definitely heard of it. I haven't personally had any hands-on experience. So the first one was the idea of basically using a database and having a model that and I would use different language. So in my world, it's, there's inference, there's predictions, and there's scoring. And when we talk about scoring, what we're talking about usually is like a relatively large data set. You score it, you run the model against that, you collect the scores, and you either set it up as a table or embed it into a new table.
So scoring
that's
for
kind
you,
of the first pattern that he's talking about. Sorry?
You mentioned scoring, that you could score a table, so like a specific set of data, or this is the output, the predictions?
So yeah, I guess scoring would refer to the output, but you're scoring like based on the input. So the scores are the output. And I guess in terms of like the group of people I work with, we use that term to denote that pattern. So when we talk about scoring, we're actually talking about that pattern specifically.
That's very cool. Okay, so scoring, I like that.
Yeah, and then there's the third pattern that he talked about, which was more this kind of online model, thinking of hosting ML models as within microservices, so that you can do batch prediction and online prediction. And I think that's a really important point. And I think without that kind of pattern that's come into existence, in a lot of ways, I think you wouldn't see MLOps be as much of a thing as it is today. And then there's that second pattern, the middle pattern that he talked about, which was more embedding the model within your application. And I haven't seen that much, but I think it's an interesting one. And I don't know. I have some thoughts around where I've heard where that is, but
nice. Yeah. I would say the same thing, man, because one is a very common pattern. I've seen that before off, like, just like reading other articles, what other companies are doing. My company did a form of that early on. And the last one is actually where we're at right now. We're doing this sort of microservices architecture. But the second one, it's funny, whenever I think about it, I'm like, I really don't know like a good example. I couldn't find like great great ways to articulate it. But I guess the gist of it is that it's going to be coupled to the application itself. It's the model is going to be a part of this overall code base, and maybe like a module, within it or something like that is how I guess I see it.
Yeah, I guess when I thought of that and I heard that, I was thinking that he's referring to embedding models into maybe even hardware, and like he's going in that direction. So like whenever you have like a computer vision model that is embedded within a camera to have edge detection, like detection on edge devices, or you want to talk about like driverless cars, you might have the model in the car because the cloud goes out, the internet connection goes out while you're on a driverless car. You don't want that to fail.
So that's a great example, actually. Yeah, I love that example. And I didn't even think about that. Yeah, like the edge of these edge devices, right? Where that's probably one example of that. I mean, I'm curious to look a little bit more into that. But yeah, dude, this is great. So shall we get started and start picking apart each one of these and just chopping it up? You guys ready? Yeah.
But first, I totally forgot that I didn't even introduce you two. So people are like, who are we?
Who are these dudes?
In case you don't know who I am, I'm Demetrios. We've got Byron Allen, another meetup guest that was rocking when was it, like a month or two ago, talking about Kubeflow versus MLflow. Check out that talk if you have not seen it yet. And of course, my man, Senor David Aponte, who's here with me in the coffee sessions, as always.
This is not Starbucks, by the way.
And I feel bad for the people who are listening to this on podcast because they cannot see that shirt you are rocking. And he's got a few buttons unbuttoned already in case anybody needs to see it. I have to bring my shirt A game. So I
love that.
Poncho. I stole.
You guys are blowing me out of the water. I'm just t-shirt.
We were thinking like, should we let him know that we're gonna wear like some like extravagant shirt? We're like, nah, we'll let him
for the next time.
For the next time.
Next time.
Exactly. So anyway, now we can get into it. I think those were some right and good intros. Very quick.
Ooh, your audio disappeared. You went on mute.
Yeah, it did. All good though, I guess.
Oh, I went on mute. So so I had a question right off the bat, like about this section where it talks about like, so it says 1, 2, and 3 can be considered an evolution of the architects as well. 1 is the fastest to get something out of the door if the input domain is bounded. And that's what I didn't understand what they were talking about. And so it goes on to say, and you want to serve the first model right off the bat to be able to prove customer impact and business value with the model. So
that's a great question, and something that I was talking to my coworkers about these yesterday. So let's talk about that. What does he mean by the input space is bounded, and why, when that is the case, the first option actually makes sense? And let's talk about the first option. So the first option he describes as materializing or computing predictions offline. Okay, so it's not in the online matter. It's not going to be in real time. It's going to be something you could do anytime. And you're going to serve it through a database. So you could store it in a Postgres database or whatever other database you want. And this idea of the input space is bounded means that basically whatever you need to know to make predictions is known at the time of when you're doing that. Like there's a finite set of options that you can basically generate predictions for, a certain set of inputs that you can make predictions for. And you're not going to include any new things to make predictions for. And maybe that's not the best way to explain it, but the idea is that, if I have let's say if I'm using like a search engine or something, my inputs are only going to be received at runtime when I'm using that application. And my inputs may be a million different things. The search space of what I could put into that is huge. I could say anything I want and people put anything they want, right? And so you can't prepare predictions for all of those options. If you did, you would have to have a huge database, right? You'd have to have something that could store all of those predictions, and you would have to know all of those inputs in advance. he gives an example at the bottom of like of why this is not feasible. If you have some sort of recommendation engine and you multiply the queries by the number of possible inputs, and the search space just explodes. So it's not feasible if you don't know, if you can't anticipate what everyone's going to say in advance. Then this sort of approach doesn't make any sense. Maybe Byron, you have a better way to articulate that, but that's like how I understand it.
Yeah, no, I very much agree with you. I think the thing that's stuck out to me when it comes to like when you talk about that bounding thing, I don't know if I would have phrased it that way, but I think you hit the nail on the head. That it's really talking about you need all your data there ahead of time, which is true for any machine learning model. But the difference is when you have a microservice, you can do that in an online manner, which online meaning live. So that really speaks to different use cases, right? Like option one, where we're talking about doing some scoring a data set, as I call it, and just stuffing that into a table and doing it all within a database. That's obviously not going to be great if you're trying to use an ML model to personalize online content, and you need that prediction in real time. There's ways to hack around that, but if you need to serve the prediction in real time, like let's say, on an app or in an online environment or in a store, and you want some sort of very live interaction, then you need that kind of online model. So I think it speaks to different use cases as well.
100%.
What is like an example of some other examples of this first case where it's like, okay, I don't need it live going right away. So it's not Netflix recommendation, or it's not an Amazon, like people also like this. What would be an example of it?
So I have one example. So let's say for my job, what we're essentially trying to do is prioritize the human genome. I want to give it some disease, and I want a ranked list of genes that that are believed to cause this disease. So I need basically a recommendation engine of sorts. The inputs to that could be a specific disease, a specific mechanism. It could be something very specific, something very general. But if I wanted to make predictions for each one of these diseases, I could do that offline using batch inference. And that's actually one way that we do it. So we basically make predictions on a bunch of diseases, and that takes a long time, but we have those UUIDs, or that information in advance. And so we can make a bunch of those predictions. But maybe if a user is inputting let's say a disease that maybe we haven't made predictions for, something that, I don't know, a new disease that was discovered or something like that, then we wouldn't have those predictions available for that. So that would be something that we would have to then do again if we were using this sort of first approach where everything needs to be known in advance. So for an example of having to like do this in an offline manner is I have this information already. I'm just going to run my model on it for a long time. I don't need there's no latency issues. I can kind of do this whenever I want, however I want. And the predictions can be made available necessarily not like in real time, but once that job is done. So for us, it's using our models to then conduct batch inference on a lot of different diseases versus, let's say for our main product, when a user is going to come in and then input a new disease. Maybe we created a new representation for this disease in our knowledge graph, and we now have a new UUID. So then the live inference endpoint is going to then generate new features and make new predictions for that. But that's something that wouldn't have been done in an offline manner. So that's like how I see this. I'm sure, Byron, you have some other good examples of scoring, since your team seems to have some good vocabulary around that.
I mean, you see it a lot in marketing because data, like models that are created behind marketing, especially the more sophisticated ones, it's not done in an online manner anyways. You basically have a data warehouse sitting there, and the data model, the ML model might just be one part of the entire marketing analytics model that leads that division to offer next best actions for customers, right? And so it all kind of, it's part of a larger whole. And if it's part of that larger whole, then it has to be done kind of in this in a data warehouse essentially. And so that's where I've seen scoring is when it's integrated into a larger system in that manner. But when it comes to like online stuff, also I would point out that the microservices bit, it's not to say that stuff that's done in a data warehouse, you could still use microservices to score things that are done in a data warehouse, and we've definitely done that because there's a lot of capabilities of the microservice that you can get out of the microservice that is really useful. Because if you're going to score something that's in a data warehouse, you still have to do that somewhere. There needs to be some sort of compute somewhere, whether that's locally or in the cloud on a VM or in some sort of container or a specialized cloud service. It will happen somewhere. So the question is like, how do you also want to monitor model performance? And I think there's a lot of benefits from looking at it from a microservice perspective, especially if you're considering pre-built tools. There's a lot of tools out there that also capture the metrics around the performance of the model, which can be very useful, whether you're looking at it from a batch predictive point of view or an online predictive point of view.
Completely.
I got another one, Demetrios. I found, I don't know if you guys have, his name is Luigi, I forget his name, but he has a blog called ML in Production. And he has like this series of deploying machine learning models, which is really good. We'll link it in the talk. But he gives a scenario where, let's say you have marketing emails. So Byron brought up the example of marketing, right? So you can get some information about these users, but you only need to send these recommendations out twice a week. So you do this stuff in advance using the information that you have about this user, and then you make predictions, and then you send them out every week. So you can do that independent of the time of sending those predictions or those recommendations. And that's I guess a really common use case, right? Where you don't need any information in real time or at the time of making those predictions, right? And yeah, I think Byron brought up a good point. It's not that you don't need that information. It's just there's different types of information that can only be received in real time. Something that that you can anticipate in advance. So yeah, that marketing is probably a big use case for this sort of model where you don't need everything in real time.
Awesome. Well, we dove into a bit this second way of doing it, which would be embedded and thinking more about the Internet of Things, stuff out on the edge, doing it that way. Is there anything else that you guys can think about with that?
Well, even before we go to the second one, I think there's some good things to talk about in the first one. Like, for example,
I'm getting a little ahead of myself.
No, you're good. But we mentioned why this is a very common pattern, right? Serving it and materializing these predictions, and why. Well, one, he gives some advantages that it doesn't require any special infrastructure, right? All you need is a database that is well suited for production. And that is generally true, right? You just need a good database. You need the ability to query the database, to write to that database. Versus let's say a microservice, you need to have some other things in place to stand that up. He also says that it's pretty fast, right? Because, if these predictions are pre-computed, all you need to do is query them when you need them. And it's rolling out, meaning deploying them and rolling them back. Let's say, for example, you have some bad predictions, you just make another set of predictions. So rolling out, rolling back is fairly straightforward. A nice thing too is that he says that it decouples the main application from the prediction serving logic. So you can allow your app to do what it does and allow the database to be responsible for handling those predictions. And so again, this separation of concerns is really nice, and it's just helpful for a lot of reasons. And he does give some disadvantages. So I guess we should start talking about that too. Like why does this not always serve everyone's use case? Byron, you mentioned that you guys are doing this. I know we've been doing this, but we kind of grew out of this, which is kind of fits in with he's saying, this evolution, right, of these different approaches. But some of the disadvantages we already mentioned. One of them is that it requires all of these inputs ahead of time. And for certain domains, like let's say a search engine, this is not realistic. There are certain queries that your recommendation engine has never seen before. So, it's just not feasible to have all of that in advance. Another thing that he mentions, which is an interesting point, is that the metadata, meaning you need to make sure that you're not just storing the predictions, but the metadata around that model, right? And it has to also be a part of what you're storing. If you want to do any sort of comparison or sort of analytics on your database, it's important to have some information about what happened at the time of inference, what model, what was the input data. Maybe there's some versioning on the data too. So for us, that was a common use case where we need to know what data model was using this, what benchmark was using this. And it also, I think this is the most difficult one for us, is that it's very hard to introduce new variables because you have to basically account for that, those new predictions, and you have to make sure that you have enough space to store that. He gives this cool example where he says if you have the number of queries multiplied by the total number of users, you're just going to have this huge search space of possible variables or queries that your model needs to serve. And so because of that, it's just really tricky. Do you guys have any other points on that? Maybe Byron, you have some things that you encounter that are tricky about this?
About number one in particular, or?
Yeah.
Number one, I think the one thing that stands out to me about number one is that when it comes to databases, you're not actually doing your compute in the database. You actually have to extract all your data from a database and then go use the ML model in some other space, in another compute engine somewhere, wherever that may be. The interesting thing to me at this point in time, if you look at like Snowflake, BigQuery, or other modern data warehousing options, there's a lot of interesting things that are starting to come out. Let's take, for example, Snowflake. They have UDFs where you could embed an API, and you could kind of you could call in an API, for example. Yeah, so you could call an API from the data warehouse directly, and that kind of cuts out a lot of that extraction of the data. You could take the example of BigQuery ML, where you can actually build models in BigQuery, and it actually hosts the model in BigQuery, and then you kind of just query the model in kind of the same way that you would query a table to get predictions. So I think to me, I wonder if in the next 10 years we'll circle back, we'll kind of go out of the database, we'll go to microservices, and then 10 years later we're just going to go back to databases, because there's a lot of compute just sitting there, and the question is okay, well, how can we take advantage of this?
That's a great point, and I didn't even think about that. This idea of and it's not really utilized fully, but maybe we'll figure out better ways to do that. And I didn't even know that BigQuery enabled that. That's a very cool model of just kind of querying the model. That's a great point.
And I should say, they're in the early days of it, so it's not, it doesn't have everything. It's not there's certain aspects of MLOps that you couldn't perform just within BigQuery. You still need to do work your way around it. But it is an interesting option that I think will mature in time, and it seems like they will mature it.
I guess it really depends upon what your domain is, right, and what you're trying to do. Because I'm thinking about that, and I'm the one really nice thing is just being able to release things independently. So I love that about microservices, that I can kind of allow my model to do one thing and one thing well. And it's tricky because then you have to orchestrate all of these things, but it's an interesting thought. Are we going to go backwards and go back to a simpler model? And I wouldn't be surprised. It's not as if we're above that. It's not, the newest thing isn't always the best thing.
Yeah, exactly. So now can we move on, or you want to?
Yes, we
keep
can,
talking?
Demetrios.
Yeah, we can move on.
I'm so excited, man. I'm so excited.
Do you have, by the way, Byron, do you have the article in front of you? I want me to just, I don't know if you want me to read it. Is that okay?
I do. I'm happy for you to point to it, read to it.
Great, excellent. Don't want to hog the conversation. But so the next approach, he calls this embedded model. And I'm just going to kind of summarize the gist of it. It's basically whenever your model is embedded into the main application. He says that it's sort of like a compromise between the first approach, where you're serving it, materializing it through a database, and the third approach, where your model's a microservice, because you're not necessarily storing those predictions, but you're also still allowed to serve those predictions in real time because it's next to the app, right? It's coupled to the app. But he does mention that, yes, it couples the serving layer with the main application, which I can imagine leads to overhead and just makes it a little bit tricky to deploy these things and to deal with them in production. But that's like the gist. Any, yeah.
I think the thing that stands out to me there is if you're coupling it with the application, and that means, so for example, if we're in an organization, if you're coupling it with your BI tool, let's say, because that's so often the case in an organization, it's like a business intelligence tool, something, you know, like dashboarding. If you're going to couple it with that, well, the question is what's the utility of that versus having a microservice or just doing it in the data warehouse, which you're querying from anyways. So with that application, I don't think it makes a lot of sense. But going back to the whole idea of doing compute on or deploying models on edge devices like, you know, driverless car or some other hardware, just maybe your phone, and that's definitely an option that you can do. And I've seen that. That's there. But then the question is do you want your model on those devices? Do you feel happy with that? Or is it safe? Is it secure? There's certain security questions that maybe come up.
Sure.
Yeah.
There's
I was
also
just going to ask
the idea of reporting back.
Like what kind of security questions would those be?
Well, the model has to sit there on the device, right? So if you're very protective about your IP and your model, and there are definitely a lot of organizations that are, you might want to figure out a way to obfuscate it, make sure it's encrypted in some way. That's really what it is. It's really about protecting your IP. So if you have a very custom model that you view as like your competitive advantage, you would have to really think long and hard about, you know, how you do that, and if it's really what you want to do, and also if it's necessary. Like with the case of driverless cars, you know, I am pretty sure that all the models are on the car themselves, because if they're querying a microservice in the cloud and the connection is cut, you know, that's too long. There's issues there. There's latency issues.
So he actually, that's one of the advantages he articulates about the second approach of this embedded in model, is that you don't have to make a network call. And that can be good for a lot of reasons, right? Network calls, especially if it's like an expensive process, something that takes a while, you're waiting in between, and a lot of things can go wrong. And then you may need to have some things in place to deal with that. Like maybe you need Redis, you need a message broker. There's certain things that you need to have in place to like make sure that when you're doing things over a network, that things are stable, right? Things go down all the time. And I think, this idea of not having to necessarily make that call because it's embedded into the device probably makes it obviously faster. But then, it's vulnerable. It's if you have a way to get into that machine, then you can get that model, which I'm sure there's some people that can definitely do that. I'm sure it's, you know, there's some people that are very capable, but I haven't, you know, I noticed that when people bring up security, like I suck at it. Like I'm never concerned about that. You know, I've only recently been growing in my appreciation of security because of my SREs. You know, the site reliability engineers in my company have, you know, that's very important to them. And I guess I get their points, you know, like this, it's a very important thing to consider. So I'm glad that you brought that up.
Byron knows. He's been around the block.
A little bit. I think to me, that's the one that stood out as security, but also it's like necessary. And to your point about latency, like that is a huge benefit in this space of like being able to have that that predictive capability faster. And certain applications, like if you're doing computer vision, that's really critical.
You can't have you need to take in, like, let's say someone walking, you need to be able to identify that as fast as possible. Latency is crucial there, right? So definitely.
Exactly. Lives depend on it. I mean, the downside to it is, and maybe it's not a downside, it's more just like, you know, people who do this these embedded models, they need to figure out a way to report back on the model performance and have that capability built into their system. Because, you know, at the end of the day, it's great that you have a model, but the whole idea of like MLOps is to understand how well your models are performing, particularly with that live data. So like being able to report back is crucial if you're going to embed models.
Yeah. He also says another advantage is that you can use the same technology stack with the model. So if the same engineers that he describes as the same engineers that are working on the main application can easily make changes to the model because they're all within the same stack. Plus, you don't need any separate infrastructure because the model can use the same infrastructure as the main application. And so you could deploy them and you can release them together. And again, that does reduce that overhead, and having to maintain a lot of things can be very tricky. It sounds very awesome, and when it works, it's awesome, but it definitely can be tricky getting there. So yeah, let's talk about the downsides, because there definitely are, right? That, you know, this may not suit your use case, and if you're not, you know, you're doing some sort of edge device, this may not make sense for you. And I think one reason why maybe this may not make sense for a lot of people is it's not really scalable. If you need to use more than one model, all of these models need to be part of that same application. So not only does that create a bunch of overhead, but then you kind of have to maintain two of these things in the same place, in the same way. And if you want to add all these new models, then you need to account for all that extra memory, whatever extra constraints, whatever. You have to make sure that the application can handle that. And you can't separate those concerns. So it's very difficult to help this change and evolve and increase, or sorry, to meet, like, I guess, increase resources or increase demand. You're kind of stuck with whatever you have. And I'm sure there's definitely ways around that. Again, like you said, with all these approaches, it's not as if you're stuck with doing one thing in one way. There's always ways to kind of hack your way around that. But yeah, I think for it just off the bat, it's not as flexible or robust as a microservice, you know, that can scale horizontally. It's kind of you're stuck with one thing.
And I would like to just say real quick, if there's anybody out there listening and they are using this way of serving models, I'd love to hear what you're using it for, like what your use case is, why you're using it like this, what made you choose it, because it seems like this is the most obscure out of all of them, right? Like this is the one that we're a little bit like, yeah, if you're not on edge, then you're not deploying onto the edge, then what else would you be using it for? So if anybody is using it,
that's pretty much my question too. So, but I think the edge example is a great one because like that makes total sense. The model has to be with like the application or the device, whatever it is. Like you can't really have. I mean, I guess you could separate them, but then you have that network call, and depending on what sort of application, that can be tricky. Like I can imagine. I don't know if you guys seen that new Amazon box. It's like this cool edge device box that can. It has it's used as a virtual machine in the back end. It has access to S3. Like it has all these cool capabilities. But I can imagine that having to separate the network calls can be very tricky. He also, I think we said this already, but one advantage is that you can use the same technology stack, but that can also be a disadvantage. Maybe you want to use your model, you want to build your model in Python, but for whatever reason, you already have this, this legacy application that was built in Go or something, and it's really good at doing what it does. And you don't, you can't mix and, if you have a microservices, it doesn't matter. They can both be two completely different things written in two completely different languages. But if they're on the same application, I'm sure there's a way to do that, but I feel like that sounds very difficult to, I guess I know of examples of using two different languages in a single code base, like R and Python. That's pretty common. But yeah, it's tricky, I guess, to orchestrate maybe these dependencies and things like that.
Yeah, and it increases the bloat on those applications and devices. So if you're trying to be lean about something, and you have a special legacy model that uses two code bases and lots of different packages, you might need to rewrite the model completely just to get it embedded.
Yeah.
And this may be a bit off topic, but is that what Sidecar is? When people talk about sidecarring, is that when
that's a sidecar pattern is when you attach basically a container to your pod that can, I use it to connect to an S3 bucket. So when my pod is instantiated, it basically connects to the S3 bucket and kind of uses it as like a directory. So it's just deploying another container to do something that is not, it's part of the main application, but it's like a separate thing. Like for example, my main application may be training the model, but I also need a container to make sure that I have S3 access and it's connected to that. So it's like a sidecar, I guess, this idea of like having an extra container on the side.
I see. Okay, cool. So I was way off.
All good, all good. And then, yeah, I think this last point is probably one reason why I would really avoid this, is that it couples model deployment with the development of the main application. So you can't really, you have to deal with both of these things at the same time. It's very hard. Like, let's say your model has a bug, then you have to basically, temporarily, I guess, stop your application depending on how people are using it. You have to go address that. It's not as I guess smooth of a process. He mentions a couple of things. It's just that the deployment depends upon the model deployment depends upon the main application deployment. And I mean, that sounds like a small point, but again, it does create a lot of overhead when you can't deal with these things independently of each other. You can't fix them independently. You can't upgrade them independently. You can't roll them back independently. And that, again, depending on your use case, that may be very important. I can imagine someone like Netflix or a website or someone needing the ability to make changes, but still have their app stand and work at full capacity. They need to do what they're doing, but also be able to make changes, and it's very hard to do that if either everything's coupled together.
So now number 3.
I think so. Yeah. I mean, any other comments on the second one? I feel like, I wish I knew more about edge devices. I need to learn.
Not really. I mean, I think it kind of highlights the beauty of putting things in microservices, actually, and the beauty of putting it behind an API and making it queryable.
That's a great.
I think there's a reason why there's not that many of us who know or have a deep knowledge of embedding ML models into applications. And the people that I know that have had that experience, they're more application developers rather than ML engineers. Anyways, they need access to an ML model, and they kind of use whatever framework is required for them to do that.
Yeah. I think that's a great point that, the second approach will make the microservice approach much more attractive for a lot of reasons. So let's talk about that. Yeah. So he says this third approach is called microservice model serving. And in this architecture, you have a model being served as its own separate microservice. So it's something completely independent from the main application. He says that this is the most flexible in terms of deployment, but also has some disadvantages. So it's not a perfect system. It definitely won't fit everyone's use case. And I definitely want to highlight that, because oftentimes people think that this is the only way to serve or deploy a model. And that's certainly not true. There's much simpler ways. This may not be the best way to do it. It really depends upon your use case, what infrastructure you have in place. Let's start chopping it up and talking about this. What are the advantages of that? I think we've kind of already been implicitly talking about them, but let's spell them out. And the first one is
that you both really like this one more than any of the other ones.
Let me preface it. It's not that I really like it. It's just it ends up working the best for, I guess, my use case. And I'm sure, I don't know, Byron, maybe for you, you use maybe a mixture of things, but to me, this is actually the one that makes the most sense for our application, our product.
I see a lot of value and utility in this option, and that's why I like it. But I think you have to definitely caution it with, it is more complex. It is more complicated in terms of development, maintenance, and everything that comes with it is overhead, and it ultimately will be tech debt for whoever is doing that. Also, there's a lot of different routes of doing it. You can go full custom and have your own Kubernetes clusters, and you can all do it in your own containers, and you can make it fully just like you own it. And we've had people in the MLOps community talk to that, but then there's other options where it's maybe more like open source, and they have that option. Selden's an example of that, or maybe it's more enterprise oriented, like Algorithmia. They've given that example. Or you have something that's more cloud vendor focused. So like all the cloud vendors have an option to do this, and all 4 of those routes come with pros and cons. And so it's to me, it's kind of it's a super interesting space, because I think there's a lot of benefit that people get out of it, but you have to navigate it, and there's a lot of options to digest.
There definitely is a lot of options. Like we just had an interview with Paperspace. They have a way to do that. You mentioned Algorithmia. They have a way to do that. Yeah, there's a lot of different ways to do this, which I guess makes it tricky, you know, because it's like, there's no one right way to do it. You just gotta, I guess, experiment a little bit. Demetrios, you had a question? You were gonna say something?
Yeah. No, yeah, I was just gonna talk about that exact same thing. Like there's so many different ways to skin a cat, right?
Yes.
I guess I think you have to know yourself, and you know how you like to skin your cats. But as you say, Demetrios,
yeah, it wasn't the best metaphor. I realized that after I said it.
Sorry, all you cat lovers.
Yeah, no, I love cats. I got a cat running around here somewhere. It was a metaphor. It was a bad one at that.
It's
it
true.
Works.
You have to understand. It does work. You have to understand what your values are for your organization, your team. You know, because there's examples where, you know, they've chosen not to go with any kind of established tool because they want to pursue integrating the way of building these microservices into something they've already built for their business. They want to make sure that it complies with that. And to do that, maybe you can't use a tool. And, you know, some tools, they preference certain ways of doing things as well. And that could be a blocker for you depending on what your use case is.
Oh, that's a great point. Yeah, I remember we saw that a bunch when I was working at Dot Science. It was like, oh, you guys, you do it like that? Or can you do it like this also? What if we have this architecture? Because nobody's architecture is the same. And so you would get a lot of that. And also I was going to mention that these guys that are doing it where they're fully custom, just starting from scratch, there's a whole, you got to have a pretty serious team around that. It's not something that one data scientist is going to be able to do, or
definitely not
a few of them. So
you need an infrastructure team of sorts. You need people dedicated to that itself. And that, I think this is a very important point, maybe a little bit tangential, but it is important that, you know, right now it seems like an ML engineer, data scientist kind of has to know everything. I anticipate that over time that won't be the case. You know, little by little, there's going to be more people specializing in the infrastructure itself, because it really is its own domain. It has its own set of issues that, you know, like I have to know, because I guess it's just how things are now. But I could definitely see people being dedicated to that, like a whole specialty of just ML infrastructure engineers, because you need to be there. It's hard to do. At least from what I've seen, and to me, it's still it's a tricky thing, you know, just all these new things that come up, like how do you load balance, how do you route, how do you have the right number of resources to make sure that, you know, everything doesn't crash. There's so many things that need to be set up in place to make sure that it runs smoothly, and it's very hard to do all that and develop a new algorithm, and, you know, do your data science. It's just that is his whole, you know, its whole own thing, right? Where and it has its own set of skills, and right now it's kind of like a little bit of everything.
Yeah, I couldn't agree more. I mean, I think you will see it become kind of a specialization, and it'll have to be that way, because you need people that can appreciate how a model is developed, and certain aspects of development of what needs to happen to build models, but also like how it was built impacts how it runs, right?
Yeah.
And how that impacts your infrastructure and what you need from your infrastructure. And so you do need a multidisciplinary individual or teams. And I think until there's specialists, you'll see teams. It'll be interesting to see how it actually like turns out. But I mean, I think one of the problems at the moment is that teams, at least, are often very siloed. And I've definitely seen teams where it's like teams of data engineers are like, oh, I don't want to touch ML. And data scientists are like, oh, no, that's not me. And it's almost like they're afraid of each other, or they see it as oh, that's not my job kind of thing. And you know, that can be hard to navigate from a like company cultural standpoint. You know, you need to get people on the same page in order to really nut out the issues at play.
Yeah, and you brought like I guess you were kind of hinting at that, but because they usually have different concerns, a different focus, and the data scientist is focusing on maybe finding the right rich information to put into this model, the right features, the right algorithm, doing some experimentation. An ML engineer is kind of in between that. He's thinking about how do I productionize it, so he's very close to maybe the ML infrastructure team, but it also has to understand the algorithmic implementation. Then you have like a SRE that is just focused on making sure that everything runs, that it's secure. They're very different concerns. And I don't blame people for, just wanting to do, one thing and one thing well.
Yeah.
Sometimes I feel bad for these quote unquote full stack data scientists, which I don't even know what that means, but for people who do it all. It's I don't know if it's
controversial
loaded
term.
Yeah.
Yeah.
But it just I don't think it's the best use of people, if that makes sense. And you even brought up an important point of how that shapes a team, like a team culture, right? Like how do you guys work together? And yeah, things can be very siloed, and I kind of get it too, because it's like, man, I just want to focus on my thing. I can't keep up with all the changes that are going on there, man. It just moves too fast, and it can be overwhelming. At least that's how I feel sometimes. Like, man, this whole space moves so fast, and there's just there's a new paper on a new algorithm coming out. There's a new tool to serve models. There's all these new things, and to be really effective, you kind of have to buckle down and do a few of those things well. Maybe you could learn a little bit here and there, but I find that it just seems you have to be like all over the place, jack of all trades.
Master of none.
But yeah, we digressed. Sorry, guys, but let's. Oh, good. This is important.
It's all a part of it. Yeah.
Yeah. So I think the first advantage, we've kind of already talked about this. I feel like I've said that a few times, but let's just keep doing it. Is that you can deploy and release your model in a very flexible way if you have it as a microservice. I can, let's say in one repo, through maybe a GitLab CI job, I can release my model. I could tag it. I could roll it back. I could delete that tag, create another one, and then in my other, let's say, repo that's maybe orchestrating all of these models, release that independently, deal with that independently. So again, these two things don't have to be coupled together. You can address them separately, and that can be very, again, I think for a lot of use cases, that's very important. For me, it's important because oftentimes like, let's say at my company, we have an orchestration system that is already complicated enough, and it deals with its own issues. Maybe we have security issues about because we use multiple clusters. So we have like a development cluster, we have a staging cluster, we have a production cluster, and one can only talk to another one. And so there's some tricky things there. And I want to allow my main application to focus on that, the orchestration system to focus on doing that well. And I can release and deploy that independently. My model, on the other hand, just has the logic that is specific to that model. It doesn't have to worry about Airflow. It doesn't have to worry about Kubernetes. It just has to focus on training a model and producing predictions. And so for that reason, I like it a lot, that it separates those concerns.
Couldn't agree more. I think separating those concerns out is really important. It allows a level of decoupling. So I mean, I've often talked about like scoring and like online prediction. So microservices, they're going to enable both of those use cases. You're not tied down to just one in that instance. And it helps you manage dependencies, because if you think about microservices, what are we really talking about? We're talking about containers, whether that's through your own system or through a tool that you're working with. It's all containers. I can't actually think of an example where it's not.
Yeah. I love containers. Demetrios, let me ask a quiz question. What's a container, Demetrios?
Oh man.
Remember I told you.
Yeah. I've been studying this. It's a bit, so how far deep down on the stack do you want to go?
Just like like high level, what is a container? What does it do?
It runs your application without having to. It can like talk to the kernel, but it doesn't need to be like its own, sorry, I'm getting confused now. You put me on the spot, man.
I know. Sorry, guys. I like to mess around with Demetrios.
So Wait. I got this. Hold up.
You got this, bro.
I got this. Let me just.
Okay.
I was here enjoying my watermelon, listening to this conversation.
David done fucked it up.
No, a container is something that really it's containerized, so you don't have to worry about it like spilling over. It runs one thing or or various applications, but usually it runs one, and then everything is involved in that one container. You don't run it like it's not like it's on a virtual machine or another computer, and you don't have to like worry about if I update one thing on here, is it going to mess up this container, right? Like
I think the basic gist you got it is that it has like its own environment, like its own little thing to do what it needs to do. I think the way I expressed it to you, I thought you were gonna remember is a box. It's like it's a little box that has everything it needs to run its code. And Byron brought up this idea of dependencies. So let's say you have a Python application, it needs to have those Python packages installed in that. Maybe it has a specific version of Python. You can have complete control over that runtime environment for whatever that app is running in there. And that's very, very helpful. Docker changed my life because I was dealing with dependency hell working locally. And this is like the bad habits I learned as a data scientist. I was just, notebook here, notebook there. When I learned about containers and containerizing stuff, I was like, this is awesome. And it's awesome for a lot of reasons. One is that obviously you could deal with those dependencies, but then you could share it really easy. You could run it if you have Docker set up, you could just, build that image, run it, and then you have everything you need. You don't have to worry about all of those dependencies. And I think that is super awesome. But yeah, you're right. Every microservice is going to have a container in the back end. So yes, containers are everywhere.
So last thing, should we talk a bit about like the difference, the ability to scale, or do you feel like we touched on that enough?
No, I think that's a good point, right?
Yeah, that is a good point, and it definitely ties into the microservices thing. I think the ability to scale, you're not really going to scale well with embedded models. And if you're talking about the first one where we're talking about models on data warehouse, well, it's not really a model in the data warehouse. Sans maybe a few options. Microservices really help you scale. And that kind of goes back to a Kubernetes conversation, really, and how Kubernetes works and how you can horizontally scale. And that's critically important for any kind of online prediction capability, especially if you get really large spikes all of a sudden for that service, whatever it might be. You'll need to scale up very quickly. And so, yeah, it is really important.
It's funny how Kubernetes really is just everywhere. I feel like I love Kubernetes. I love what it has it just makes it really easy to have scalable applications. But I wonder, is there other cluster orchestration systems that people are using frequently and that I just don't know about? Because literally the only one that I could really think of is Kubernetes. I don't know, does anyone know of any other ones?
Docker Swarm.
Yeah, okay, yeah, it's true. It's a container, yeah.
Are you thinking for specifically?
Yeah,
are you thinking for horizontal scaling specifically, or for?
No, I guess just for orchestrating your cluster. Is there? I mean, it seems like Kubernetes is the biggest name right now, but is there?
Yeah,
I can't think of another one.
Docker
Swarm.
There's some other more advanced stuff that isn't really containers that I've heard about, but I couldn't really speak to it. There's stuff that there are attempts at trying to make a lighter version of containers that spins up quicker than containers. And I think those are still a little ways out, or maybe that'll kind of go the way of beta versus VHS kind of scenario. I'm not sure, but
good. No.
Yeah. Kubernetes is definitely the main one right now.
Yeah, it is. And let's Demetrios, just so we break that down. So when we mean you can horizontally scale, is that you can, let's say I have one application. Remember, we were talking about Kubeflow serving. One cool thing about Kubeflow serving is that it allows you to build a serverless application. And serverless is just this idea of it's kind of off, or it's sleeping or it's dormant. And when a user hits that endpoint or actually calls that service, then it spins up. Usually a pod is going to spin up, and it's going to start running your application inside of a container. And let's say the traffic, like for whatever reason, the traffic just increases to the endpoint. It could add more machines. So again, it could horizontally scale, and it could add more and more as much as it needs. And then let's say, things chill out a little bit. Eventually, it will scale back down. And that flexibility of being able to add more resources when you need it and use less resources when you don't need it is very important for companies. Like for us, it's not only about cost efficiency, but just about being able to deal with the load. It's very hard to configure all of that in advance when you're building some sort of small service, and what you can, but oftentimes it'll maybe crashes because of outer memory issues or things like that. So having the ability to quickly add more things is really, really nice. And I guess this is typically associated with a microservice, because that microservice itself will be running on, some sort of in the back end using Kubernetes and some pod, which has the ability to do that. And like, I guess you could do that if you're running like your embedded model in the main application, I guess, but maybe I feel like it's a little bit trickier. I'm like thinking, could you do that? Could you, like, if it's running on one pod, couldn't you just add more machines?
Well, I mean, but then you're also kind of spinning up the application. If it's coupled with the application, then you're re-spinning up the application. It becomes, I guess, redundant, and I don't think it would work that well.
Yeah.
I mean, the only other like time where you can see clustering kind of come into the conversation around ML is if you're looking at like Spark, which is definitely a different type of cluster and does different things, but it can be useful for scaling certain like optimization workloads. So like not necessarily ML, but like more like signal processing type stuff. I've seen and done that before, and cool. So it kind of depends. There's that kind of secondary thing, which that's less about horizontal scaling, but cluster.
But just having something that can adapt. It's like to me, this in simplest terms, that's what microservice, like the gist of it, of when I explain it to someone who doesn't know any of this stuff, is that it has the ability to change and grow when it needs to, or to get smaller again, I guess. And that is really helpful. The ability to flexibly, to change. And if not, you have to know kind of the environment in advance, and you have to configure it so that you have to know, let's say, what type of traffic it's going to have. And you have to make sure that you put enough resources, enough CPUs, enough memory. If not, again, it's up to you to constantly make those changes manually versus having it do that automatically, having the ability to automatically increase or decrease when it needs to.
Well, and I think in this article too, he talks about how the microservices model is what everyone should be aspiring towards, even if you don't get it right in the first time, but it's something that like should be where you're trying to get to. So I think you guys reiterated that point.
There's a lot of utility in like we've talked about the like horizontal scaling and the ability to address like larger workloads, but there's also things that like canary modeling, which this person speaks to in his article, which is really powerful in terms of assessing what model is appropriate at this given point in time. If you have a canary, the idea of concept drift is really important in ML, and if you see concept drift, you could use that as triggers to implement or try another model, or you want to know just at a more basic level with canary models, like how is your current model performing and should you go to something else?
Canary model, can you just go over that real fast? The canary model is when you do what?
So canary model is a second model that would take in this X amount of your live data, right? And that's configurable, something like 10, 20%. If you deem it to be an appropriate model or a better model than your current default model, you might promote that to production. So it's a way of automatically deploying models into production without it being a manual process. And
it's basically like A/B testing.
Yeah, it's similar to A/B testing. You could use A/B testing to do kind of this, essentially the same thing, to automate the deployment of a model into production. And there's a lot of, this gets into the question of like, what do you set as a trigger for retraining as well. And
yeah, that's a hard
you know,
one.
if you have a new model, then you want to kind of introduce that to the equation in a way that doesn't impact or like your production environment. You can do that through canary modeling, for example.
And so it allows you to kind of like separately like try out new things at the same time. And again, I could see that being. I would love to hear from anyone listening to this. Any people that are actually doing something like this, I would love to hear more about it, because I think, yeah, I have definitely some more to learn about the interesting ways that you could actually not only deploy a model but promote one, like you said. Configuring it so that certain events will trigger something else. Let's say maybe retraining the model or promoting a different endpoint with a different version of the model. I haven't had to do that yet, so I'm super curious to see like how are people doing that. What are some of the best ways to do that? So for anyone listening, keep that in mind and reach out to us.
Yeah, you can reach out to us on Slack. We have the Slack community where all three of us are there. We are active and we enjoy talking to anybody who wants to talk. So,
and I want to say something real quick, because he does, the author does basically close by saying that, you know, this is like what you should aspire to. I actually don't agree with him on that point. This is just my personal opinion. I don't think that this fits everyone. Again, you have to have the right infrastructure in place. If you don't have that in place, then you're going to have to go through a lot of pain points just getting to that place where this actually works smoothly. And if your company isn't at that level of engineering maturity, then there's no need to try to do this. Martin Fowler, I think I talked about him in the last session, but he has this whole series on microservices, and he makes it very clear that sometimes a monolith or having one thing that has like all these things put together works well. It gets the job done. And you should only move to a microservice when you have, I guess, certain things in place. You have not only just the infrastructure, but even like, I would say like the engineering capabilities, because, you know, does a data scientist know how to stand up all of these things and orchestrate them? Does he know how to configure the load balancer, whatever it is that's going on in the back end? You may not need to worry about all of that yet. Maybe the first pattern works well enough. And I would just say, really, there's no perfect way. It's really what works best for you and your company, for your use case. So while it's cool, I think this, like me and Byron would agree, this is like probably my favorite approach, because it's fun, you know, to like build a service. But I'm only able to enjoy that because I have an ML infrastructure team that has a service that allows me to do that easily. So I can enjoy it. I can play around it. But if you have to set this up on your own, I think it'll be a little tricky. So I just want to say that yeah, this may not be the best one for your I guess whatever your use case is.
Totally agree. It's such a case by case scenario. You need to do you.
Exactly. Do you.
So this has been another coffee session. I am super happy to have you both here with us.
This is a lot of fun. Byron,
I didn't get the memo.
I already had coffee
session
this morning.
or the shirt part. Next time he's gonna come prepared.
I will say, it was a pleasure. I love your calm demeanor. You explain things very clearly. You guys should reach out to him.
Thanks,
he's a really cool guy.
He's an influencer on Medium. If you haven't read his work,
I haven't. I got it.
Oh,
you gotta send me one of the. No, I have not. I haven't. I mean, Medium has a lot of different people on this. So like, you got to Byron. Maybe you could share something with me after this, because I want to.
Yeah. I'll send you a link.
Put it in the show notes.
Definitely. It's really good to meet you too, David.
And if anybody wants to come on here and teach me what a container is, we're always open for it. I need many different ways.
I'm sorry if I sounded me. I really. I was just trying to be like a little teacher. Hey, do you remember what I said? Type of thing.
No, that's how you learn, through quizzes.
That is
totally
true.
Cool.
That's true. You gotta use the stuff that you learn. So what's a container to me?
You'll get there. It takes time.
I'll get there. Byron's got confidence. I got confidence.
I believe in you, bro.
There we go.
Believe in you.
I got you two believing in me, and you're taking the time out of your day to help me understand this and learn this. So I appreciate that, guys. Now, that's it. Join our Slack community, MLOps community. Talk to us there, and be ready for another coffee session. I think we're gonna try and talk about something else cool. Feature stores.
I forget what's in the books. Huh?
Feature stores, maybe.
Feature stores. That's a big one. I'm actually.
It's an interesting one.
Airflow is another good one. Yeah, both of those are really good. Maybe we should you guys should vote for it. What do you guys want us to talk about next? Do you want us to talk about Airflow? Do you want us to talk about feature stores?
Show us in the comments.
Yes. So we're not even going to tell you what we're going to do. You're going to let us know, and then we're going to do it.
Yeah, exactly. All right, y'all.
Awesome. Bye, guys.
Peace.
Take care, everyone.
See you later.
Okay, I stopped.